New Zealand-born British physicist, Ernest Rutherford was better known as the pioneer of experimental physics. He was the first to explain the detailed structure of an atom, both theoretically and experimentally. But, still his theory lacks accuracy. In fact, Rutherford's theory completely failed to explain a stable atom. We are to discuss here the two main reasons for which Rutherford's theory failed. Although his brilliant student Niels Bohr found amazing solutions to these failures later on, using his stunning quantum theory. But, for now, let's look at the error number 1. Rutherford's model proposed that an electron can revolve around the nucleus, along all possible orbits. What does it imply? It indicates that, between any two orbits, there should exist innumerable possible orbits. And, it gives an electron opportunities to transit from one orbit to other, in an infinite number of ways. An electron, now, can move from orbit 1 to orbit 2, through innumerable paths. Thus, it can release energy in many different ways. And, its atomic spectra could have innumerable lines of frequency. Remember, during a transition, from a higher orbit to a lower one, an electron emits energy, in the form of electromagnetic wave. For each transition, an unique frequency of electromagnetic wave generated. Hence, a line of ray added to its spectrum. If electrons transit in a million number of ways, then the frequency would have been millions. Let's take some examples. Suppose there is no other orbit between orbit 1 and orbit 2. An electron gets only one possible way to transit, which is orbit 1 to orbit 2. In this case, only one transition occurred. Therefore, only one line spectrum is generated. If there exists another orbit between them, say, orbit P, the electron now gets two different ways to transit. First one is orbit 1 to orbit 2. And the second one is orbit 1 to orbit P, to orbit 2. A total of 3 transitions can be seen there. For all these transitions, 3 lines of rays are generated. If 2 orbits exist there, then, the electron could transit in 4 different ways. Orbit 1 to orbit 2. Orbit 1 to orbit P to orbit 2. Orbit 1 to orbit Q to orbit 2. Orbit 1 to orbit P to orbit Q to orbit 2. Here, the total number of transitions is 8. Corresponding spectrum may contain 8 lines. If 3 orbits exist there, then the electron should get a total of 8 different ways to reach orbit 2. Therefore, total number of possible transitions would be 20. Hence, one could obtain a 20 different rays. For a larger number of orbits between them, larger ways can be seen, and larger number of lines of ray would be generated. Therefore, atomic spectrum should contain innumerable wavelengths and frequencies, which we called a continuous spectrum, and it looks like this. But, sadly, this not the spectrum, what we observe. Actually, an atomic spectrum contains a limited number of wavelengths and frequencies, which looks like this, and it is called line spectrum. Error number 2. Perhaps, the biggest failure in Rutherford's model is the stability of atom. Rutherford's atomic model could not expand a stable and long-lasting atom. It describes every electron to revolve the nucleus through a circular orbit, in such a condition that its centrifugal force remains equal and opposite to the electrostatic force between electron and the nucleus. But, electromagnetic theory predicts that an accelerated charged particle should emit electromagnetic waves.
Since electron is accelerating in its orbit, it should emit electromagnetic waves. Thus its total energy should decrease over the time, meaning, its orbit to decrease over the time. And, after a finite duration of time it will collapse on the nucleus, which may be called as the death of an atom, or the end of an atomic state. Is it the reality? Of course not. Atoms never die, or never lose its property. Thus, Rutherford's model could not explain a stable atom.
Hope you realized the topic and understood it clearly. Like and subscribe this channel to get more such content.